Hello guys, welcome to my channel. So this is the part 2 of the series that I am currently working on, where I will be discussing on the most asked interview questions based on microservices architecture. So this is the part 2 of this video. If you haven't seen the part 1 of this series, then please have a look at my channel. Now before we move towards this video, if you are new to my channel, if you haven't subscribed to my channel yet, please do. Now let's see what we have in this video. So first question is, what are blast radius and resiliency? So talking about blast radius first, so it is the area of the potential impact that a deployment might have. So let's say if you have to deploy a new feature to your website, the blast radius might be the website itself. But if you are deploying a new database schema, the blast radius might be the database and all the applications that use it. The problem with deployments is that they often have an infinite blast radius. While we always expect some blast radius, an infinite blast radius means that anything could go wrong and cause problems. Now talking about resiliency. So the problem with distributed applications is that they communicate over a network, which can be unreliable. Hence you need to design your microservices architecture in such a way that they are fault tolerant and handle failures gracefully. In your microservice architecture, there might be a dozen of services talking with each other. You need to ensure that if one service fails, then it doesn't bring down the entire architecture. So in layman terms, blast radius is going to be something which is going to affect your part of application or your entire application. So blast radius is the probable area where you can see the problem, right? So it could be your entire application or it could be a part of the application. So wherever you are making a change, that could be your blast radius, or wherever the regression is going to be, that could be your blast radius. Resiliency is something like that. Let's say if we do something, then we have to ensure that it is not affecting other part of the application. So if something goes wrong, then we have to make sure that the entire application is not going down. Now second question is how to make your services resilient. So first is to identify failure scenarios. Now how do we do that? So let's say if service A is not able to communicate with service B. So this is one way to identify. Second is that your database is not accessible from your application or from the part of your application. Third, your application is not able to connect to the file system. So wherever you are putting your files or downloading, importing your files, let's say that directory or that server is not responding. Now your server is down where you have installed your application or deployed your application. Fifth, inject faults, delays into the services. So these are some of the identification where you can identify failure scenarios. Second, avoid cascading failures. Now, when your architecture includes service dependencies, you need to make sure that one failed service does not have an impact on the entire application. Avoiding cascading failures will enable you to maximize thread usage, convert network resources, and allow the failing service to recover. This is pretty straightforward. Now, avoid single points of failure. It is always a good idea to consider how your microservice application will function if a specific component goes down when creating it. That will promote healthier conversation and aid in the development of a fault-tolerant service. But be careful not to design your services so that they rely heavily on a single component, and if that occurs, be sure to have a plan in place for quickly recovering from the setback. So in your entire application, if there is a part of module, or if let's say there is a core module which is being used by your entire application or all of your modules, then be sure to make this in place that if your core module is going down, then all the other modules are recovering quickly. Handle failures gracefully. Now, your microservices should be designed to be fault tolerant. That much is pretty clear, which we have discussed in other points as well. Now, if mistakes or exceptions occur, the service should manage them gracefully by returning a default value or an error message. Your microservice must be fault tolerant and gracefully manage failures. So this could be one of the example where, let's say, if something is going wrong, it doesn't mean that we have to exit our application abruptly. We should always manage those exception or mistakes in a graceful way so that we provide enough information to the user as well as to someone who is going to debug this error or exception. So this could be one thing that we can keep in mind. So this was all that we have to do if we have to make our application resilient. Now, next interview question is, what is circuit breaker pattern? So this is a very important interview question, and this could be asked if the interviewer or the project believes in heavy microservices architecture. Now, why do we need circuit breaker pattern? Each service in a microservice architecture structured application can be separately created in an agile way to enable continuous delivery and deployment, CI/CD. These services frequently engage in microservice interactions. An unavailability or overload of a service is always a possibility. The calling service will likewise wait in this scenario. Performance will suffer if numerous services are blocked, and this might have a cascading effect on the entire application. Now, this is why we need circuit breaker pattern. Now, what does it do? A circuit breaker is a mechanism used in microservice based applications to stop an erroneous method from being executed and reroute all incoming requests to an appropriate custom method, which is your fallback method. In most cases, if a method is consistently throwing an exception, we halt its execution. We also prevent any cascading failures to the downstream services when we interrupt the circuit. Its fundamental job is to stop current flow when a fault is found. Either manually or automatically resetting a circuit breaker will allow it to restore normal functionality. Now, this circuit breaker is not a term which we use in technical or in software development terms. This is a terminology being used from our grid. So if you see how the electricity flows from a grid to our house is where circuit breaker plays a role. So circuit breaker is a hardware which faults whenever something is overloading or some wire is overloading. In that case, circuit breaker breaks, and that is going to be the identification in our entire electricity line, like where exactly it went wrong. So if, let's say, in a particular electricity line there are 10 circuit breakers, if a circuit breaker breaks, then we can tell that this is the place where something went wrong, and then we can easily work on that. And maybe in case if it is going wrong, we can also try to think of some ways so that we can restore things quickly. And that is the terminology or fundamental concept being used in microservices as well. So circuit breaker is something which is being used to halt or stop an erroneous method from being executed. And if we are getting failures multiple times, then we want to halt its execution. Otherwise, we will reroute it to a custom method which is going to be a fallback method. And that is what a basic circuit breaker design pattern do. Now, what is a fallback method in microservices? If an actual method of a microservice is throwing exception continuously, then we avoid execution of the actual logic for some time. Instead, we redirect the request to a dummy method that provides the response back to client's request. Such dummy method is called fallback method. This method can provide dummy responses such as some service not working, unable to process, try after some time, etc. This you might have seen even on your Amazon application or your famous e-commerce websites. So this is what a fallback method do. Now, why do we need a circuit breaker? It is very common for software applications to make remote calls to software program, and remote calls may fail or hang without a response until some timeout limit is reached. Now, if you have many requests on an unresponsive service, then you can run out of critical resources, leading to cascading failures across multiple systems. The basic idea behind the circuit breaker is to wrap a protected function call in a circuit breaker object which monitors for failures. Once the failure reaches a certain threshold, the circuit breaker fails. Now, there are some states of a circuit breaker. Depending on the state, circuit breaker changes its behavior. There can only be 3 states of a circuit breaker: closed, open, half open. Now let's talk about these states. So closed, if client request is sent to the actual service method only, then it is called as closed circuit. Hence, this state represents that the service is running properly and providing the expected functionality. Now open, if client request is redirected to fallback method, then such case is an open circuit. Hence, this state represents that service is unavailable or faulty and error rate is beyond the threshold. Half open means once the state becomes open, we wait for some time in the open state. After a certain period of time, the state becomes half open. During this period, we do send some request to service to check if we still get the proper response. If the failure rate is below the threshold, the state would be closed. If the failure rate is above the threshold, then the state becomes open again. This cycle continues till the service becomes stable. Now next question is, what is two-phase commit and Saga pattern? Now, why do we need these patterns? The microservice architecture has many advantages over the monolithic architecture, but transactionability just performs better on monolithic system, since the database is present to ensure ACID properties. It is similar to implement the ACID properties in a monolithic system. However, if the same system is partitioned into numerous microservices, the same transaction might be split into numerous distributed local transactions that are called in a particular order. To make sure that the services don't wind up with globally inconsistent data, these distributed transactions create a lot of challenges. Now let's take this example. A user is logging into Amazon on his laptop. Now to check the area availability, Amazon will go to the database to see if it could be delivered to the user's location or not. If it can be delivered, then only the user can add it to the cart and then get the product delivered. So this is a rough representation of Amazon in a monolithic architecture. Now the rough representation of Amazon in microservices architecture is divided into 3 different modules to do the order management, inventory management and logistic management. Here logistic management is doing the delivery and checking if it could be delivered to the user or not. Inventory management is checking if there is enough inventory of that product that user wants to order. Order management is obviously just going to order or add to the cart for the user and then order it to the user. So this is the rough representation of microservices architecture. Now the idea behind telling you guys about the microservices and monolithic representation of Amazon is to explain this theory. So here we are talking about ACID properties, which is atomicity, consistency, isolation and durability. It is much easier to do or ensure these ACID properties in a monolithic system because this is going to be a complete package and it's easy to manage those transactions or those ACID properties. But if we have different modules, then doing that separately and then collectively is going to be difficult, and that is what we are talking about in these design patterns. Now let's talk about two-phase commit first. The prepare phase and the commit phase are the 2 stages that two-phase commit separates the transaction into. All the services involved are requested to get ready for a transaction during the prepare phase. Once all the services acknowledge the prepare they were asked to commit the transaction is aborted globally in all the associated services if any service answers negatively. To do this, a transaction coordinator is needed, which controls every step of the transaction lifecycle, provides preparation instructions to each microservice, and monitors their responses. Now, what are some advantages of using two-phase commit? The entire transaction is unsuccessful if even one service late in starting up. Otherwise, everything goes as planned. This makes sure that all the global transactions are always of an atomic nature. Data corruption has a very low probability. Since data is only accessible when the global coordinator commits the modifications, here we have read-write isolation. If the sync call returns a success response, the transaction involving the microservices as a whole was successful. So here we have covered ACID properties. Now, what are the disadvantages? Now, two-phase commit locks down resources for an extended period of time, requiring each service to maintain a hold on its resources until the transaction is finished. Long locks on the objects result from the total transaction taking longer, because there are more microservices involved. Because of this, it is only useful in a specific circumstance and should not be used in other situations. On a transactional system with high throughput, this strategy is inapplicable. Additionally, two-phase commit needs a separate service to serve as a transaction coordinator, which adds to the management and scalability challenges of this service. The single point of failure in two-phase commit is the transaction coordinator. Now, the third point leads down to your resiliency. Now, talking about Saga pattern, which is better than your two-phase commit. The main issue with two-phase commit was that it was synchronous, which led to long locks. In contrast, the Saga design is asynchronous, which is reactive, which makes local transactions perform quickly on individual microservices. The event bus is used to asynchronously start these local transactions. The concept behind this is that anytime the source service makes a change, it emits or it creates an event that the dependent service can then listen to make the necessary modifications. The source system can respond by executing its compulsory logic if one or more of the downstream dependent service fails. Advantages. Fast local transactions are a key benefit of the Saga pattern. A high throughput system can employ this since no microservice depends on any external services, which makes local transactions very quick and shortens locks on resources. And this was one of the disadvantages of two-phase design pattern. Now, talking about disadvantages, a Saga pattern flow containing numerous microservices might become complex, have multiple points of failure, and require additional maintenance for the event bus. In case of a problem, complexity also extends the amount of time needed for troubleshooting, which means debugging is going to be difficult. All local transactions do not need to be in sync. Read isolation is not required because the individual service transaction does not wait for other services. If there are any queue delays, this issue will be even worse. However, the systems will eventually become consistent. Even if the initial checkout call to order the service, which served as the sync call response, may have been successful, this does not guarantee that the entire transaction will be successful. Now, here we are talking about the example that I showed of the rough representation of Amazon. So even if the initial checkout call to order service, which served as the sync call message, is successful, this doesn't mean that the entire transaction will be successful. So I hope that this is clear. If there is any kind of a question on any of the interview topic that I talked about in this video, please let me know on the comment section. This is it for this video. I will continue working on this series and post more videos further on. So stay tuned for more. For now, have a good day, stay safe, and goodbye.